one more question before you go. The very last part of the unit guide deals with linear quadratic systems. So when you have a quadratic function, you can have a quadratic function and a straight line, and you can either have two intersection points. We're just going to do one more example. You can have one intersection point, or you can have 0 intersection points. Okay? So you don't have to copy down the graphs, you just have to know there are 3 different types of scenarios. So in the very last assignment, you're going to be given, determine the number of points of intersection of the quadratic function and the linear function. So I have a quadratic function, I have a linear function. And even though we're kind of solving using substitution the same way you did in grade 10 when you had 2 linear functions, it's almost the same. So the first thing we're going to do is you're going to set your y equal to y. So I'm going to set 2x minus 2 equal to x squared minus x minus 6. And in order to find out how many, it's not saying find the exact intersection points, it's just saying the number of points. So we're going to end up using our discriminant that we talked about in the last seminar. But first we need to get just combine those 2 equations so I have only one equation. So I'm going to move everything on the left-hand side over to the right-hand side. So I have x squared minus x, bring the 2x over, so I have negative 2x minus 6 plus 2. And when you solve that out, you get the final quadratic equation. 0 is equal to x squared minus 3x minus 4. And we use the discriminant. You should remember this from last year. The discriminant does not have a square root. It's just b squared minus 4ac. And from this equation, I know that a is equal to 1, b is equal to negative 3, and my c is equal to negative 4. So I'm going to plug that into the equation. Negative 3 squared minus 4 times a times c. So negative 3 squared gives me a positive 9. Negative 4 times 1 times negative 4 is positive 16. So we get, this question is equal to positive 25. Because d is greater than 0, we're going to have 2 distinct real roots. For this question, that's the answer. So you're going to have 2 distinct different intersection points. If d was less than 0, you would have no real root, so no intersection points. Oh, sorry, not distinct real roots, because we're talking about intersection points, not roots. So 2 distinct intersection points. D is less than 0, you would have no intersection points. And there's one more situation that you need to know for your unit guide. When d is equal to 0, you're going to have 2 equal intersection points. And that's another way of saying just 2 equal intersection points just means 1 intersection point. So let's change that so you don't get confused. we'll change that to 1 intersection point. Okay? So this unit is very different from the other ones because it's kind of like fragments from different parts of the grade 10 course all put together, and this is the only new concept that you really learn, but it's very similar to something you learned last year too. So just try your best. Please check Edmodo for, I'm going to try to keep it updated with videos of the hardest questions, and any mistakes in the unit guide, I'm writing that all in Edmodo, so please check it regularly, okay?